Hi, folks, welcome back. I hope you're all doing well. Formal methods often get a very bad rap with practicing software engineers because they feel like it's too complicated, too hard, and does not deliver enough value. So it was refreshing to see this experience report about how the engineers over at Amazon Web Services applied formal methods to some very central parts of their system. So, why do we need formal methods? Systems like AWS are large and complex distributed systems, and it is notoriously hard to find and detect subtle bugs in such systems. And when you do have bugs, they can lead to really nasty things like data loss or data corruption. The other thing is that the standard array of methods that we use in software engineering, things like design reviews, code reviews, static analysis, fault injection, and so on, that otherwise give us high confidence that a system is functionally correct, are not enough to guarantee that certain properties are met. Like Dijkstra famously said, testing can only show the presence of bugs, but it cannot prove the absence of bugs. When we talk about using formal methods, there are two levels at which we can apply it. The first level is to use formal methods to prove that your design or your specification is correct with respect to some high-level properties of the system. For example, you might want to prove that your distributed storage system never loses a write. The second level at which one could apply formal methods is to then prove that the code meets the specification or meets the design. What the authors are talking about in this paper is the former, which is they want to specify their design formally and prove it correct with respect to some high-level properties that they want it to satisfy. What prompted the authors to consider using formal methods was that they had built all these large distributed systems, and while they were successful, they still suffered from ongoing bugs and operational issues. So basically, what they needed was some way to know for sure or to prove that a class of bugs was completely absent from the system. In their search for a tool to apply, they wanted something that could precisely express the design yet was high level enough for humans to work with and comprehend. And finally, they settled on TLA Plus, which is a formal specification language designed by Leslie Lampert and implemented by a team at Microsoft Research. This paper doesn't go into the details of TLA Plus because it's more of an experience report, but at a very high level, TLA Plus uses model checking to exhaustively check the correctness properties that you want your specification to satisfy. As I was saying at the beginning, most software engineers have a skeptical attitude towards formal methods because they feel like they're really hard to understand and apply to real-world software and don't deliver enough value. However, the authors here are reporting that their experience at Amazon has been quite the opposite. They have managed to get formal methods usage into their culture of software engineering, have used it on 10 large real-world systems in AWS. And the benefit that they have seen is that in each of these cases, applying TLA Plus has found subtle bugs at the specification stage itself before hitting production. And moreover, using these formal methods, you can also make optimizations while knowing that the overall system is still correct. They mentioned that the mindset of an engineer when starting to build a system using traditional methods versus using formal methods to specify their system is very different, because traditionally engineers will think about how to implement the common path or the happy path, and then they will think about all the corner cases which go away from that happy path. Whereas when you're using formal methods, the mindset you approach the problem with is to first come up with a definition of what needs to go right, or what are the properties or guarantees that you want your system to specify. And these usually come in two flavors. you have safety properties. These are things that the system is allowed to do, or in other words, the bad things that you want not to happen. And the other common class of properties are liveness properties. And these are things that you want the system to eventually satisfy. A safety property could be, for example, that all data is written correctly and is not corrupted. An example of a liveness property is that you eventually respond to every request. Here we see a table of some of the systems that they have applied formal methods to. And PlusCal over here is simply a higher level language that is easier to understand, but it gets compiled down to TLA+. As we can see, for their storage system S3, they were able to take some of the very core distributed system components and specify them in a pretty reasonable size specification. And as you can see in this table, in almost every case, they found very, very subtle bugs at the specification stage itself. These are all bugs that did not hit production. A crucial part of adopting a new method like this is to change the software engineering culture in the organization. And this experience report talks a little bit about how the authors did that. They had some initial success with using TLA Plus on DynamoDB, and they then went on to try and talk about these methods and persuade the broader engineering community inside Amazon. This was a grassroots effort, but this success was noticed by management, and ultimately they bought into it as well. So that was a quick look at an experience report about how engineers at Amazon have successfully applied formal methods to some of their largest and most complex distributed systems, and indeed found many subtle bugs at the design phase itself. So that's quite an encouraging story for the application of formal methods. I hope you found that useful, and I will see you next time. Thank you very much.